Hello everybody, we've got a new circuit to analyze. Let's read the problem. The problem tells us to find the current I in the circuit by applying node voltage analysis. So let's take a look at our circuit. We see that the current I is the current flowing in the right branch of the circuit through the 1 ohm resistor. We see that the circuit has a middle branch that has a constant 24 volt voltage source in series with a 10 ohm resistor. And on the leftmost branch of the circuit, we see two resistors in series, one 4 ohm resistor and one 6 ohm resistor. Now what's our first step? Our first step is to firstly simplify the circuit by combining the two in series resistors. This will just simplify matters for us. So we know that to combine two in-series resistors, we simply add their resistance. So we'll replace these two resistors with one resistor with a combined resistance of 10 ohms, and that's what we've done here in this drawing here. So now what's the second step of the circuit? Second step of the problem. The second step is we're going to label all nodes in the circuit, and this is what we do whenever we're doing node voltage analysis. We always label all nodes in the circuit. And that's what I've done right here in this redrawing of the circuit. I've labeled that top node with V1. Look, we'll call that top node node 1 and we'll label it V1 for voltage 1, which is the voltage at that node. The next step of the circuit, step of the problem is to find an expression for the current I. We want to do this first before doing our Kirchoff's current law at that node, because we want to find an expression for I, because I is the term that we're solving for. So let's do that. Let's find an expression for I, the current I. Now we'll take a look at this. This current. This current is flowing through this 1 ohm resistor, and it's flowing from top to bottom. So applying Ohm's law, we'll say that the current I is going to be equal to the voltage at the top of the 1 ohm resistor minus the voltage at the bottom of the 1 ohm resistor divided by that 1 ohm resistance. So now what does this give us? The voltage at the top of our 1 ohm resistor is V1, and the voltage at the bottom of our 1 ohm resistor is 0 because it's grounded, and the resistor has a resistance of 1 ohms. So I is going to be equal to V1 over 1 ohms. That's going to be our expression for the current I in the circuit. Now our next step is to apply KCL at node 1 to solve for V1. See, we have an expression for I now in terms of V1, but we need to solve for V1 in order to complete that expression. So let's do that. Let's go ahead and apply KCL at node 1 in the circuit. So here I have redrawn the circuit, and now I've drawn these three outgoing currents from node 1, I1, I2, and I3. And by Kirchoff's current law, I1 plus I2 plus I3 must equal 0. So now we're going to need to go about finding an expression for I1, I2, and I3 in terms of V1. So let's find our expression for I1. Just as we did with solving for I, let's consider this current going through this resistor and solve for what it is. So the current is flowing from top to bottom of this 10 ohm resistor in the leftmost branch of the circuit. So this current is going to be equal to the voltage at the top of that resistor minus the voltage at the bottom of that resistor divided by the resistance of that resistor. And that's going to be V1 minus 0 divided by that 10 ohm resistance. That's because V1 is the voltage at the top of the resistor, 0 is the voltage at the bottom of that resistor, and 10 ohms is the resistance of that resistor. So that's what we've got right here. I1 is going to be equal to V1 minus 0 divided by 10 ohms, or equal to V1 over 10 ohms. Now let's find an expression for I2. Let's look at the circuit again. I2 is the current flowing from top to bottom of the 10 ohm resistor in the middle branch of the circuit. So I2 is going to be equal to the voltage at the top of that 10 ohm resistor minus the voltage at the bottom of that 10 ohm resistor, all divided by that 10 ohm resistance. So the voltage at the top of that 10 ohm resistor is V1 again. The voltage now at the bottom of that resistor is 24 volts. And the resistance is 10 ohms. So the current I2 is going to be equal to V1, which is the voltage at the top of the resistor, minus 24 volts, which is the voltage at the bottom of that resistor, all divided by 10 ohms, which is the resistance of the resistor. Now let's find an expression for I3. So I3 in this circuit is actually equivalent to I, and we've already found an expression for I. So I3 is equal to I, which we know is equal to V1 over 1 ohm. So now let's create our expression. Let's create our KCL expression again. KCL is equal to KCL tells us, the Kirchoff's current law tells us that I1 plus I2 plus I3 is equal to 0 amps. So we said that I1 was equal to V1 over 10 ohms. I2 was equal to V1 minus 24 volts over 10 ohms. And I3 is equal to V1 over 1 ohm. And all three combined together is equal to 0. So now let's solve for V1. We have all of our terms in this problem in terms of V1. So let's solve for V1. So first thing we can do is multiply by the least common denominator, which is 10, and that gives us all across V1 plus V1 minus 24 volts plus 10 V1 is equal to 0. So simplifying this down, we get 12 V1 minus 24 volts is equal to 0. And using our commutative property, we've got 12 V1 is equal to 24 volts, or adding 24 volts on both sides, I should say, gives us 12 V1 is equal to 24 volts, and V1 is then equal to 2 volts. So that's our new expression, or that's the value of V1. So now step 5 in the problem is to plug the value of V1 back into our expression for I. So what is our expression for I? Can we remember it? Let's go back and see. Step 3 of the problem was finding an expression for I, and we found that I is equal to V1 over 1 ohm. So I gave us V1 over 1 ohm, and now we know that V1 is equal to 2 volts. So 2 volts over 1 ohm is equal to 2 amps. And that's the solution for our problem. I, which is the current through the rightmost branch of the circuit flowing through that 1 ohm resistor, is equal to 2 amps. That's the current I.